they had us at the executive office run the HAZIS runs to create those flood damages. We had this data and they wanted a way to view the data. So we had this developer named Lizzie Slavinsky, a really sharp woman, and she built this tool for us for Toledo. And it's a JavaScript library and built on Node.js. So it's basically a web map. Take the tool, we'll kind of step through all the parts of it. You can learn more and it'll go to a page where you can download the report and get the data. But let's just click off that and I'll show you the tool real quick. So what you're looking at, these circles are the flood damage results out of HAZIS. So what we're looking at here is, this is a scenario, the current precipitation and land use scenario. This is a 100-year, 1% annual chance of flood. So if you click on each of these properties, you can see what the damage is. Now, we're under this scenario, current precipitation and land use, but those other scenarios we can switch to, I'll show you in a second, are also shown on this graph. So the ones that are being displayed on the map are the 100-year with the orange line. You click off here, you can change the scenario. So instead of the current precipitation and land use, you switch it to the current precipitation with green infrastructure, and the circles mostly all shrink. Based on the models that we were given for the depth grids, these are the HAZIS results. Then you can also take a look at each of the different the flood chances. So it's a unique way of looking at the data, where normally you would just have, we have 4 scenarios with 6 return periods. That's 4 times 6, 24 different shape files, and it's really kind of cumbersome. You put that in GIS or clicking around, turning things on and off. But this tool allows you to see things visually, and it's striking the way that she built it, definitely with an eye for design. So if we go back to there, then you can look at the other scenario, future precipitation with green infrastructure. This is they're expecting more flow, so the damages are a little bit higher. And again, you can click across each one of these and see the different damages for each one. Some of the other things that we have in here, we've got land use. So you can turn on the land use. You can see the current land use. You can see future land use. Pan the map all around and see those things. We got watershed boundaries, NFHL. You can change the base map as well to like satellite or terrain. So kind of basic online map web functionality, but built with an eye for design, and it's striking. Some of the other really cool things on here are, I can get this to scroll. So depending on the scenario you've chosen and the return period, these statistics will change. So if you go to future precipitation with current land use, you can see the mean flood damage, or current precipitation with green infrastructure. You see those numbers in this box right here that they're changing. So that's averaged across the entire data set. And then charts is another way of viewing the data. So this is the 100-year flood given current precipitation with green infrastructure. We can see that there are 53 properties that are at the 7% damage, HAZIS like 7%. And then the other thing that's really cool is the histogram on the bottom. Let's show you the pie chart first. So just different ways of viewing the same data in a visually compelling way, and then also in a line chart. What I'm trying to find, data distribution. Oh yeah. And then you can also export out the data as a link. So whatever you have in the viewport at this time with whatever layers you have turned on, you can click this export as a link, and it'll create a URL that you can send to someone, and it'll go directly to the thing that you were viewing. But this histogram on the bottom is also the damages, but it's tied to the map. So you click around and you can go around, and then if you switch your scenario, this is my favorite thing on the bottom, it's graphically stunning. I could do that all day. And that's built with a JavaScript library called D3. It's also built with Leaflet, which is a JavaScript library for the map. And it's all built on top of Node.js, which is server-side scripting, but written in JavaScript. So the entire app is written in JavaScript. So you're not writing stuff in PHP, and not to get too geeky here, but you're echoing out HTML, and you're writing in different languages and different documentation. It's all written in JavaScript. Lizzie has showed this off at a conference called FOSS4G, Free and Open Source Software for Geospatial, North America, and was offered a job in Buffalo and has since left us. So if you know any good JavaScript developers, but we have this code available, so if you have developers, this is all open source. We can give it to you, you can build it. You run the HASIS, you spit it out, you put it in a JSON, .js or JavaScript object notation, and this will just run with whatever data you throw it in. You update the data layers from like ArcGIS Online. We're using ArcGIS Server to store those other data layers, pushed into ArcGIS Online, and then ingested into this. So it's a hybrid. It's not 100% open source. We're a hybrid shop, the executive office. We find whatever tool works best, and so ArcGIS